Let me tell you about a question that has haunted me for 60 years. What was before the Big Bang? It seems like such a simple question. Everything has a cause. Everything comes from something. If the universe began 13.8 billion years ago in a hot, dense state we call the Big Bang, then surely something must have existed before that. Something must have caused it. Something must have been there. But here's what 6 decades of physics have taught me. This question might not have an answer. Not because we haven't found the answer yet, but because the question itself might be fundamentally confused. We might be asking about something that doesn't exist. We might be using words that have no meaning in the context we're applying them. And I want to be honest with you about this. Most videos about the Big Bang will give you a list of theories: eternal inflation, cyclic cosmology, string theory landscapes. They'll present these ideas as if one of them is probably correct, as if we're just waiting for better data to decide between them. But that's not the truth. The truth is messier, more uncertain, and in some ways more interesting. Today, I want to take you through what physics actually says about before the Big Bang, what it doesn't say, and why the question itself might be the problem. This isn't a lecture about cosmology. It's an honest reckoning with the limits of what we can know. Let's start with something that might seem like a technicality, but is actually the heart of the matter. The word before implies time. When you ask what happened before some event, you're assuming that time extended backward past that event. You're assuming there were earlier moments, previous instants, a temporal sequence leading up to what you're asking about. But what if time itself began at the Big Bang? This is not a new idea. It goes back to Augustine of Hippo in the 4th century, who was asked what God was doing before creating the universe. His answer was that the question was meaningless because time itself was part of creation. There was no before, because before requires time, and time didn't exist yet. Einstein gave this ancient intuition a mathematical form. In general relativity, space and time are not separate things. They're woven together into a single fabric called space-time, and this fabric is not a fixed background against which events happen. It's dynamic, shaped by the matter and energy within it. When we trace the universe backward using general relativity, we see space-time contracting, curving more and more sharply, until we reach a point where our equations break down. This is the Big Bang singularity, a point of infinite density and infinite curvature where the mathematics gives nonsensical answers. But here's the crucial point. In this picture, space-time itself emerges from the singularity. There is no space-time before the Big Bang because before is a temporal concept, and time is part of what's emerging. Asking what came before is like asking what's north of the North Pole. The question uses words that don't apply. Stephen Hawking made this point vividly. He imagined space-time near the Big Bang not as something rounded off, like the surface of a sphere. On a sphere, as you travel north, you eventually reach the North Pole, but there's nothing north of it. The concept of north simply doesn't apply there. Similarly, as you trace time backward toward the Big Bang, you might reach a point where the concept of earlier simply doesn't apply anymore. This is not a dodge. This is not physicists avoiding a hard question. This is taking the mathematics seriously and following it where it leads. If general relativity is correct, then time might have a beginning, and asking about before that beginning might be as meaningless as asking what's north of the northernmost point. Of course, general relativity might not be the complete story. We know it breaks down at the singularity. We know it's incompatible with quantum mechanics. We know there must be some deeper theory, quantum gravity, that takes over when space-time curvature becomes extreme. And in some of these deeper theories, there might be a before after all. Let me walk you through the leading candidates. Not to tell you which one is right. I don't know which one is right, and neither does anyone else. But to show you what physicists have imagined, and why none of it is certain. Eternal inflation. The standard Big Bang model includes a period called inflation, a tiny fraction of a second during which the universe expanded exponentially fast. This inflation explains several puzzling features of our universe, like why it's so uniform and why it's geometrically flat. But some physicists, notably Andrei Linde and Alex Vilenkin, have argued that inflation might not have stopped everywhere. Our observable universe might be a bubble where inflation ended, but inflation might continue eternally in the space beyond. constantly spawning new bubbles with different properties. In this picture, there is a before our Big Bang, a bubble nucleated within an eternally inflating space that existed prior to it. That inflating space might have always existed, or it might have had its own beginning, pushing the question further back. Is this science? I'm not sure. Eternal inflation makes predictions about patterns in the cosmic microwave background, but the predictions are contested and the observations are ambiguous. More problematically, the regions beyond our bubble are causally disconnected from us. We can never observe them, never test them, never confirm their existence. Some physicists think this makes eternal inflation untestable and therefore not really science at all. Others disagree. The debate continues. Another possibility is that our Big Bang was not the beginning, but a transition. The universe might be cyclic, oscillating between periods of expansion and contraction, with each Big Bang being the beginning of a new cycle. This idea has a long history, going back to ancient Hindu cosmology and revived periodically by physicists. The modern version, developed by Paul Steinhardt and Neil Turok, draws on string theory. They imagine our universe as a three-dimensional membrane floating in a higher dimensional space. When two such membranes collide, the collision creates a Big Bang, and our current universe is the result of the most recent collision. In this picture, there definitely was a before. There was a previous cycle, a previous universe, perhaps an infinite sequence of universes stretching back forever. Time doesn't begin at the Big Bang. It continues through the transition from one cycle to the next. Is this testable? Steinhardt and Turok claim it makes different predictions from standard inflation about gravitational waves in the early universe. So far, the observations haven't clearly favored either model, and the underlying physics, string theory, extra dimensions, brain collisions, remains unconfirmed. We're building speculation on top of speculation. Roger Penrose, one of the great mathematical physicists of our time, has proposed yet another cyclic model. In his conformal cyclic cosmology, the universe goes through infinite cycles, but the transition between cycles is different from Steinhardt and Turok's version. Penrose argues that in the far future, after all matter has decayed and only photons remain, the universe will lose any sense of scale. When everything is massless, distances become meaningless, and a universe with no sense of scale, Penrose claims, becomes mathematically equivalent to a universe at the Big Bang, which also has no sense of scale because everything is compressed to a point. In this picture, the infinitely old, infinitely cold end of one cosmic cycle smoothly becomes the infinitely hot, infinitely dense beginning of the next. Our Big Bang was the end of a previous cycle, and our universe will end by becoming the Big Bang of the next cycle. Is this testable? Penrose claims to have found Hawking points in the cosmic microwave background, circular patterns that would be remnants of black holes evaporating in the previous cycle. But other cosmologists are skeptical. The claimed patterns might be statistical noise. The mathematics is elegant, but elegance doesn't guarantee truth. Perhaps the most radical approach is to apply quantum mechanics to the universe as a whole. In standard quantum mechanics, systems are described by wave functions that evolve according to the Schrödinger equation. What if we write down a wave function for the entire universe? James Hartle and Stephen Hawking attempted this in the 1980s. Their no-boundary proposal imagines the universe's wave function in a way that eliminates the singularity. Instead of time beginning at a sharp point, space-time is smoothly rounded off, like the surface of a sphere. There is no boundary, no edge, no moment of creation. In this picture, asking what came before the Big Bang is like asking what's south of the South Pole on Earth's surface. The question assumes a structure that isn't there. Time doesn't begin. It just smoothly curves around and connects to itself. Is this the answer? I don't know. Quantum cosmology is mathematically beautiful, but it's also incomplete. We don't have a full theory of quantum gravity. We don't know if the Hartley-Hawking wave function is the correct one. We do know how to interpret a wave function of the entire universe when there's no external observer to collapse it. I've now described 4 different approaches to before the Big Bang. Each is mathematically sophisticated. Each is proposed by serious physicists, and each is, in my honest assessment, Speculative. Let me be clear about what I mean by speculative. I don't mean these ideas are foolish. I don't mean they're not worth pursuing. I mean that we have no observational evidence that distinguishes between them. And in some cases, we might never have such evidence. This is uncomfortable for physicists. We like to think that every question has an answer, that every mystery will eventually be solved. But the question of what came before the Big Bang might be different. It might be the kind of question that science cannot answer, not because science is limited, but because the question is asking about something that doesn't exist. Think about it this way. If time began at the Big Bang, then, before the Big Bang, is a contradiction in terms. It's like asking what's inside a one-dimensional line, or what color the number 7 is. The words fit together grammatically, but they don't refer to anything real. And if time didn't begin at the Big Bang, if there was some kind of before, then we are dealing with regimes so extreme, so far from anything we can observe that our theories become unreliable. We're extrapolating our mathematics far beyond the domain where it's been tested. We might be right. We might be wildly wrong. We have no way to know. You might ask, if we can't answer this question, why bother thinking about it? Here's why I think it matters. First, the question reveals the limits of physics. We often talk about physics as if it can explain everything. The theory of everything, we call it. But the question of what came before the Big Bang shows us that physics might have fundamental limits. There might be questions that physics cannot answer, not because we're not smart enough, but because the questions fall outside the domain of what physics can address. This is humbling. It's also, I think, important to acknowledge. Science is powerful, but it's not omnipotent. Recognizing its limits is not a weakness, it's a form of honesty. Second, the question forces us to examine our assumptions. We assume that time flows from past to future. We assume that every event has a cause. We assume that before and after are meaningful concepts. But these assumptions come from our everyday experience, and our everyday experience might not apply at the extremes of cosmology. When we ask what came before the Big Bang, we're really asking whether our ordinary concepts, time, causation, sequence, have any meaning in this context. And the answer might be no. Our intuitions evolved to help us survive on the African savanna might simply break down when applied to the origin of the universe. Third, the question is beautiful. There's something magnificent about standing at the edge of knowledge and looking into the void. We don't know what came before the Big Bang. We might never know. But the question itself, the act of asking, reflects something profound about human consciousness. We are creatures who ask why. We are creatures who want to understand. Even when the answers elude us, the questioning itself has value. Let me share where I've arrived after 60 years of thinking about this. I don't know what came before the Big Bang. I don't think anyone knows. I'm skeptical of anyone who claims certainty, whether they claim that time definitely began at the Big Bang or that there definitely was something before. I find the Hartley-Hawking no-boundary proposal aesthetically appealing. The idea that time smoothly rounds off rather than hitting a sharp boundary feels mathematically elegant. But aesthetic appeal is not evidence. Lots of elegant theories have turned out to be wrong. I'm intrigued by eternal inflation, but troubled by its untestability. If we can never observe other bubbles, if the theory makes no falsifiable predictions about our own universe, then is it really science? Or is it mathematical metaphysics dressed up in the language of physics? I'm open to cyclic cosmology, but skeptical of the specific models. They rely on string theory, which remains unconfirmed. They rely on extra dimensions, which we've never observed. They're interesting ideas, but they're built on foundations that might not be solid. Mostly I've come to peace with not knowing. I used to think this was a failure, that a good physicist should be able to answer any question about the universe. But now I think the opposite. A good physicist should be honest about what we know and what we don't know, and we don't know what came before the Big Bang. Maybe we'll find out. Maybe some future theory will settle the question. Maybe some unexpected observation will reveal the truth. I hope so. I'd love to know the answer before I die. But if we never find out, that's okay too. Some mysteries might remain mysteries. The universe is not obligated to be fully comprehensible. We've learned an enormous amount in the last few centuries, far more than our ancestors could have imagined. But there might be questions that lie forever beyond our reach. Behind what came before the Big Bang lies an even deeper question. Why is there something rather than nothing? Even if we explain the Big Bang, even if we trace it back to eternal inflation or a previous cycle or a quantum fluctuation, we're still left with the question of why anything exists at all. Why is there an eternally inflating space? Why are there cycles? Why are there quantum fluctuations? This is the question that Leibniz asked in the 17th century. It's the question that Heidegger called the fundamental question of metaphysics. And it's a question that physics, I believe, cannot answer. Physics describes how things behave. It describes the rules that govern the universe. But it doesn't explain why those rules exist rather than different rules, or why anything exists to follow the rules in the first place. Some people find this disturbing. If physics can't answer the ultimate question, what good is it? But I find it liberating. Physics does what it's supposed to do. It describes the natural world with extraordinary precision. Expecting it to answer metaphysical questions is like expecting a hammer to write poetry. It's the wrong tool for the job. The question of why there's something rather than nothing might not have an answer. It might be the kind of question that dissolves when you examine it carefully. Or it might have an answer that lies forever beyond human understanding. Either way, physics has taken us remarkably far. It has explained the structure of atoms, the evolution of stars, the history of the cosmos. If it stumbles at the ultimate question, that's not a failure. That's just the boundary of what physics can do. I began this with a confession. The question of what came before the Big Bang has haunted me for 60 years. But haunted is perhaps the wrong word. It suggests torment, frustration, dissatisfaction. That's not how I feel anymore. Now I feel wonder. Wonder that we can even ask the question. Wonder that our mathematics takes us so close to the beginning. Wonder that human beings, evolved on a small planet around an ordinary star, can contemplate the origin of everything. We don't know what came before the Big Bang. We might never know, but we've looked further into the past than any generation before us. We've traced the universe back to the first fraction of a second. We've understood processes that happened 13.8 billion years ago. That's extraordinary. The question of what came before is the edge of our map. Beyond it, there might be more territory to explore. Or there might be nothing. Not emptiness, but the absence of territory altogether. Either way, standing at this edge and looking into the unknown is one of the most profound experiences a thinking being can have. What was before the Big Bang? I don't know. And after 60 years, I've learned that not knowing can be its own kind of answer.